Hi, I'm from Group1. Our project title is Smart Queue System for the healthcare industry. A smart queue system is an advanced type of queue management system that uses present technology like AI, data analytics, and cloud computing. The smart queue system has revolutionized the healthcare industry by offering seamless patient experience. In traditional queuing process, patients require to arrive to the hospital waiting in line until they can get doctor consultation. There is a lot of challenges and problems occur with the traditional queuing process. In order to address these challenges, the healthcare industry began to implement virtual queue systems. The potential future trend for smart queue system is AI and machine learning. Exploring recent technology and also implementing it into the system. The problem statements. The first challenge with the traditional queue process is long waiting time. Patients require to queue physically and wait in the hospital until their turn. Long waiting time can also result in overcrowding in the waiting areas. Another drawback with hospital queue is the requirement for physical presence, which is very inconvenient. Lastly, the patient record was managed manually, which significant number of staff were required to find the patient record manually and get them into the queue. We have two objectives in this project. The first one is to develop a smart queue system that helps the hospital to enhance the efficiency of the hospital. The second one is to enable the hospital to leverage the power of cloud-based data analytics, which allow them to identify peak hour congestion and also design targeted solutions accordingly. With careful consideration, we decided to build our proposed smart queue system using the Amazon Web Service. Okay, we have two types of queuing method: queue using the physical kiosk or mobile application. The kiosk scans the face of patient and send the data through API gateway, using the Amazon recognition to identify customer identity and retrieve data from S3 and DynamoDB. Then send to Lambda function to generate queue number. The queue request for mobile application will also pass from AWS Amplify through API gateway to DynamoDB and send it to the Lambda function for queue number. The Lambda function push all the queue requests to SQS and store everything to DynamoDB through another Lambda function. The data from DynamoDB will export to S3 bucket and retrieved by SageMaker Canvas to learn and calculate the estimated waiting time. Once the waiting time upload back to S3 bucket, Pinpoint send email notification through SES to customer on the queue number and estimated waiting time. Lastly, QuickSight retrieve all data from S3 for visualization purposes.
Hi, my name is Soijin. So I will present about the demonstration part of our team. So this is our team details. And this is the architecture diagram that presented by my teammates just now. Okay, we have to first log in into the AWS Management Console first. Clicking the sign in to the console, we are able to see this page. And then sign in using the root user, we can see this AWS Management Console. So moving on to the module 1, which is our step 1. First, the face recognition kiosk will capture the image, and then the image will then pass to the Amazon API gateway, and then further processed by Amazon recognition. We have to first open the command prompt and then install the AWS shell, and go back to the management console, and then create the access key. Click this security credential, and create the access key. Then go back to the command prompt, we enter this AWS configure, and then it will ask for the access key ID and the secret access key. We just copy and paste this credential inside here. So after the creation of the access key configuration of AWS, you have to create a collection for AWS recognition. Create a table for DynamoDB. Also create the S3 bucket. So you have to take note that the S3 bucket ID should be globally unique. So after this, we have to create the IAM role for each of the services. Then inside this create IAM role, we go to the role and then create the role. By following this, select the AWS service, select Lambda, go to the next, and then provide it a role name and then create this role. Create the inline policy and then change the bucket name here, and also provide the database ARN here. So how to find the database ARN? In the management console, we go to the DynamoDB and then go to the update setting of the tables, and then choose the tables that we created just now, and then copy this AWS ARN database ARN. Okay, after this, we have to create a Lambda function. So create this Lambda function, and enter, or by following this step, then create this lambda function and go to the lambda function. We add the trigger to the lambda. Go to configuration, triggers, and then add this trigger. Provide the service and then select the bucket. Okay. After this, the S3 will trigger the lambda function every time when it is updated. So the lambda function will generate the face ID and then store the image into the DynamoDB. So go back to the console after we create the trigger in the lambda. So we have to train the lambda, train the recognition. So this is the put image. This is the put image.py. This is the script, and then we run this script using the Python. So this step can train the system to recognize the image is who. So inside this lambda function triggered, we can see that the image is being inserted into the S3 bucket. Then after that, we can check the result in the DynamoDB. Go to the DynamoDB, go to the PartiQL editor, and then select the table, and then we press the run. And we can see that this DynamoDB is already able to retrieve all the data from DynamoDB. Okay. So we can see here, this is the testing.py. Okay, and then by running this, we can see that it is able to recognize the person. Okay. So moving on to step 2, a lambda function being triggered and then sent to the SQS, and then the message is being queued and then sent to the lambda function. And the things is the queue number is further updated and sent into the DynamoDB. So first of all, we have to create an IAM row. We go to the IAM, create rows for the lambda. We go to creation of the rows like just now, and then we add this policy. Then after that, we go to the SQS. We create a queue, select the first in, first out, and then provide it a name, create a queue. Next, we go to the lambda function, create the function, and then like creation of just now, author from scratch, function name, and then select node.js18, and then select the row that we created just now, create the function, go to the lambda, we add the trigger, and in the trigger, we select the SQS, and then select the queue that we created just now. So here, it says that the lambda function will receive the queue message from the SQS and then store the queue history in the DynamoDB. And this is the code. So we go to the DynamoDB, we create a table. After this, we enter these details and then also provide it a partition key. We create the table. So we can see the table is created here. And after that, we go to DynamoDB and find the table that we created just now, and then download the selected item to the CSV. We create another lambda to the incoming queue request, which is the first lambda in the architecture diagram just now. So here is we can see that after we create the lambda here, and then after the message is come inside, the message is being sent into the queue and being processed. After that, we can see the CloudWatch that it is able to receive the patient information, and the queue history was successfully written into the DynamoDB.
Okay, let me continue with step 3, which contains SageMaker and the canvas, also as well as Amazon S3. So first, we need to create a bucket. Search for the S3 bucket, and then press the create bucket button. After that, assign all the values here, and then press the create bucket button. It's successfully created. Search on console DynamoDB, and this is the page of DynamoDB page. After that, we need to navigate to export to S3 tab and click on the export to S3 button. After that, search for a queue table in DynamoDB, which we already created before, and assign a S3 bucket, which is just now we created the S3 bucket name. Just assign it here, and then choose on this account and export. Moving along with Amazon SageMaker, search SageMaker on console, then create the SageMaker on domain. Press the button here, and after that, just set up the SageMaker domain. And also with the role, enable it and then submit. The tag queue, app system is already here in SageMaker as domain, and you use the domain to open the canvas. After you load into the canvas page, the page is like this. Then you navigate to the dataset tab and import dataset. Import through S3 and search for the S3 bucket that you created just now. Click on it and import the data. Once you import finish the data, navigate to the models tab, and create a new model. Then provide the model name and press create button. Yeah, so that's it. You can select from here. After you import, you will see the dataset is here, and then you select it and select the dataset button. Yeah, so after all that, you will see after you're training with the SageMaker canvas, it will train with the estimated waiting time, which the customer are required to wait how long until their turn in line. So after they learn, the SageMaker canvas learn and train all the time, execute back to S3 bucket with you can see that with a new bucket and is executed by the canvas. Yep. Alright, so continue with step 4. This module is notification module. First, we need to search DynamoDB on console first, and then create a table. Create a table with all the details, provide a name, provide the partition key, and also selecting the default setting, and press the create table button. And you will see that the table is created. After that, you need to create a trigger function for Lambda here. Then provide the Lambda function details and turn on trigger and create trigger. Continue with Amazon Simple Email Service, SES. Search SES on console and create identity on SES. Provide all the information like your email address, and then use your email address. Provide your email address and then create the identity. After creating the identity, you need to verify, which you need to verify it through your email. An email message will send to your email, and then you just need to verify it. After you verify your identity, the identity status will change to verified. Step 5, which is the mobile application module. Search AWS Amplify in console, and you will see this page. Just scroll down and click the button Get Started on Build an App. Yeah, it's a mobile application. So once you build it, you need to enter the app details. So our app is called Duckhill App System. So we just put our name here, the app name here, and then click on the confirm deployment. So this one is the deployment page where you can wait until the setup is done. After that, it will jump to this page. You just need to press on the Launch Studio button. Then this is the Amplify Studio console page. We can set the authentication here, which link to the mobile application that our user need to provide which information to sign in or sign up. And so choose username as configure login, and scroll down to configure sign up, which include email and name inside, and also define the password policy, the length of password, and include the characters, and click on the deploy button. After deploying, you will show a pop-up with Amplify CLI instruction, and you just click on copy here on the command, then download the attached folder. Then download the attached folder and open it using Visual Studio Code. After that, pull the command in the terminal. Just now you copy the command, you just paste it here into the terminal and then run the command. Then the AWS Amplify page will pop up again once you run it, and then you just click on the yes button to log into Amplify CLI. Then set all the things to default, or just choose your default editor, Visual Studio Code, and type of app, JavaScript, React Native, and the other is default, and press on yes. Just add in another command, just copy the Amplify Add API. This API is to add the API gateway into the Amplify app, which you can just simply link it by typing in this command and then set it accordingly like this. After that, you need to add notification. This one is actually linking it to the pinpoint, and the pinpoint is assigning all the notifications to SES, which means simple email service. All right, and then also provide all the information. So you need to push all the settings to cloud and apply the command amplify push in your terminal. Then run the mobile app in your device. Providing this command and run it in your device. Prerequisite, you need to download the export app first. Right, so this is what actually will show in the mobile application interface, which this one is sign up and verify through sign up and sign in page, which you can sign up here, and a verification will send to your email. Then you use that verification code to sign into your account. Yeah, so after you sign in, the home page is like this, where it's simple and there are one button, which is the Q button. After clicking on the Q button, this Amplify app will pass all the customer details to the cloud, which will automatically store in a table in DynamoDB. So moving on with the last step, which is the Amazon QuickSight step for visualization. Search QuickSight on console. Sign up for QuickSight. Selecting the enterprise choice and then click on continue button. Then you need to select for the IAM role and also provide the region and as well as your account information. Don't forget with your email address also. On the right on the same page, you can you need to configure like this in order to import Amazon S3. So you need to tick all the datasets here. So click on finish, and after that, finish button again. After that, it will prompt this page, which you have successful sign up for QuickSight, and just simply go to Amazon site, and it will show you some of the sample analysis according to the dataset given. And you need to navigate to the datasets tab and click on the new dataset button. Click on S3, provide the data source name, which any name will do, and also a manifest file, which I import using URL according to the data that just now generated by Canvas. And press on the connect button. After that, it will prompt this. You just choose the interactive sheet and create it. Then yeah, so all your dataset attributes will be showing here, and you can simply just choose 2, 3, or 4 attributes to show on a graph. Here is some visual types, which you can just change everything according to your preference. So this is one of the example of graph generated by QuickSight with the attribute of queue request time, which you can see that at 12 PM they have the most requests on that particular time. So according to all the visualization provided, the healthcare industry can take a solution accordingly, so that the traffic is not congested in this time. Yeah, so that's the end of our demonstration. Thank you so much for listening.